Welcome to Wonderslate by Smart eBooks from the best publishers. Subscribe and turn on the notification bell.
Topic for today's quiz is Nuclear Physics. Question number 1. The function of heavy water in a nuclear reactor is to Option A. Slow down the speed of neutrons. Option B. Increase the speed of neutrons. Option C. Cool down the reactor. Option D. Stop the nuclear reaction. The correct answer is Option A. Slow down the speed of neutrons. Moderator is required in a nuclear reactor to slow down the neutron speed produced during the fission reaction so that the chain reaction can be sustained. Heavy water or deuterium oxide, D2O, is an excellent moderator due to its high moderating ratio and low absorption cross-section for neutrons. The other moderators used in nuclear reactors are water and graphite. Question number 2. Which one of the following is used as a moderator in the nuclear reactor? Option A. Thorium. Option B. Graphite. Option C. Radium. Option D. Ordinary water. The correct answer is Option B. Graphite. Neutron moderators are a component in a nuclear reactor which work to slow down the fast neutron speed to make them more effective in the fission chain reaction. Heavy water and graphite are used as moderator in the nuclear reactor. Question number 3. Graphite is used in the nuclear reactor as a Option A. Fuel. Option B. Lubricant. Option C. Moderator. Option D. None of the above. The correct answer is Option C. Moderator. Neutron moderators are a component in a nuclear reactor which work to slow down the fast neutron speed to make them more effective in the fission chain reaction. Heavy water and graphite are used as moderator in the nuclear reactor. Question number 4. The substance used as a moderator and coolant both in nuclear reactors is Option A. Ordinary water. Option B. Heavy water. Option C. Liquid ammonia. Option D. Liquid hydrogen. The correct answer is Option B. Heavy water. Heavy water, D2O, displays similar physical and chemical properties but differs in nuclear properties when compared to ordinary water, which makes it an extremely efficient material for use as moderator and coolant in pressurized heavy water reactor. Heat energy produced in the core of reactor due to fission reaction is required to be carried away by a coolant. Heavy water is used as a primary coolant to transport heat generated by the fission reaction to secondary coolant, light water. The light water takes the heat energy from heavy water and generates steam at an appropriate pressure for running steam turbines. Steam turbines drive generators to generate electricity. Question number 5. What happens if the control rods are not used in a nuclear reactor? Option A. The reactor will stop working. Option B. Chain process would go out of bounds. Option C. The reactor will be slow to act. Option D. The reactor will continue to work as it is. The correct answer is Option B. Chain process would go out of bounds. Control rods are made with neutron-absorbing materials such as cadmium or boron and are inserted or withdrawn from the core to control the rate of reaction or to halt it. If control rods are not used in a nuclear reactor, then the chain process would go out of control and hence would cause serious damage. Question number 6. The alpha particle carries 2 positive charges. Its mass is very nearly equal to that of Option A. 2 protons. Option B. An atom of helium. Option C. Sum of masses of 2 positrons and 2 neutrons. Option D. 2 positions as each positron carry a single positive charge. The correct answer is Option B. An atom of helium. Alpha. Alpha particles are helium nucleus. Alpha particles are composite particles consisting of 2 protons and 2 neutrons tightly bound together. They are emitted from the nucleus of some radionuclide during a form of radioactive decay called alpha decay. Question number 7. What is nuclear reactor? Option A. Place where atomic bomb is built. Option B. Heavy water pond. Option C. The emitter of U-238. Option D. Molecular furnace. The correct answer is Option D. Molecular furnace. Nuclear reactors are the heart of a nuclear power plant. They contain and control nuclear chain reactions that produce heat through a physical process called fission. That heat is used to make steam that spins a turbine to create electricity. Hence, nuclear reactors are sort of molecular furnace. Question number 8. Which one of the following elements is essential for the construction of nuclear reactors? Option A. Cobalt. Option B. Nickel. Option C. Zirconium. Option D. Tungsten. The correct answer is Option C. Zirconium. Nuclear reactor contain and control nuclear chain reactions that produce heat through a physical process called fission. That heat is used to make steam that spins a turbine to create electricity. Zirconium, being hard, corrosion resistant, and transparent to neutrons, is used for the construction of nuclear reactors. Question number 9. Enriched uranium is Option A. Uranium sticks laid in particular shell. Option B. Natural uranium in which radioactive U-235 isotope increased artificially. Option C. Mixture of natural uranium and thorium. Option D. Chromium-coated uranium sticks. The correct answer is Option B. Natural uranium in which radioactive U-235 isotope increased artificially. The nuclear fuel used in a nuclear reactor needs to have a higher concentration of the U-235 isotope than that which exists in natural uranium ore. Uranium enrichment is a process that is necessary to create an effective nuclear fuel out of mined uranium by artificially increasing the percentage of uranium-235 which undergoes fission with fast-speed neutrons. Question number 10. Which uranium isotope is used in nuclear power plants to produce electricity? Option A. U-233. Option B. U-234. Option C. U-235. Option D. U-239. The correct answer is Option C. U-235. Question number 11. Which metal is used to generate electricity? Option A. Uranium. Option B. Iron. Option C. Copper. Option D. Aluminum. The correct answer is Option A. Uranium. Question number 12. A breeder reactor is that which Option A. Does not require fissionable material at all. Option B. Uses only heavy water. Option C. Produces more fissionable material than it burns. Option D. None of these. The correct answer is Option C. Produces more fissionable material than it burns. Breeder reactors are unique in their ability to produce more fissionable material than they consume or burns. A conventional nuclear reactor can use only uranium-235 isotope for fuel, whereas a breeder reactor employs either uranium-238 or thorium. Question number 13. Fast breeder reactor is a nuclear reactor producing electricity which produces electricity. Option A. By fusion process. Option B. With the help of solar cells. Option C. By burning fuel substances used by it and by its reproduction. Option D. By using as refiner of hard water. The correct answer is Option C. By burning fuel substances used by it and by its reproduction. Breeder reactors are unique in their ability to produce more fissionable material than they consume or burns. A conventional nuclear reactor can use only uranium-235 isotope for fuel, whereas a breeder reactor employs either uranium-238 or thorium. Question number 14. Consider the following statements. In a nuclear reactor, self-sustained chain reaction is possible because 1. More neutrons are released in each of the fission reactions. 2. The neutrons immediately take part in the fission process. 3. The fast neutrons are slowed down by graphite. 4. Every neutron released in the fission reaction initiates further fission. Which of these statements are correct? Option A. 1. 2 and 3. Option B. 1 and 3. Option C. 2 and 4. Option D. 2, 3 and 4. The correct answer is option B. 1 and 3. There is a release of extra neutrons in the fission process. The extra neutrons in turn can initiate fission processes, producing still more neutrons and so on. This leads to the possibility of a chain reaction. If the chain reaction is controlled suitably by the control rods made of graphite, a steady energy output could be received. This is what happens in a nuclear reactor. Hence statements 1 and 3 are correct. Question number 15. Which one of the following cannot be used as nuclear fuel? Option A. Uranium. Option B. Thorium. Option C. Calcium. Option D. Plutonium. The correct answer is option C. Calcium. Nuclear fuel is the fuel that is used in a nuclear reactor to sustain a nuclear chain reaction. The most common nuclear fuels are uranium-235 and plutonium-239. Thorium-232 can also be used as nuclear fuel. Calcium, Ca, atomic number 20, is an element, alkaline group metal. It is a very ductile silvery metal whose properties are very similar to heavier elements in its group, strontium, barium and radium. Question number 16. The important nuclear fuel available in India in abundance is option A. Uranium. Option B. Thorium. Option C. Cadmium. Option D. Beryllium. The correct answer is option B. Thorium. Thorium is available in India in abundance, which is being used as nuclear fuel. Thorium, despite its greater abundance in nature and a number of superior characteristics, lags behind use of uranium as it does not have any fissile content. The fertile thorium-232 has to be converted into uranium-233 first for use in a nuclear reactor. Question number 17. Which one of the following is the source of renewable energy in stars? Option A. Hydrogen changes into helium. Option B. Helium changes into hydrogen. Option C. Decay of radioactive material. Option D. Excess of oxygen, which is helpful in burning and generate energy. The correct answer is option A. Hydrogen changes into helium. Most stars including Sun is made up mostly of hydrogen and helium atoms in plasma state. Sun generates energy from a process called nuclear fusion. During nuclear fusion, the high pressure and temperature in the Sun's core cause nuclei to separate from their electrons. Hydrogen nuclei fuse to form one helium atom. During the fusion process, radiant energy is released. Question number 18. The energy from Sun is released due to option A. Nuclear fission. Option B. Ionization. Option C. Nuclear fusion. Option D. Oxidation. The correct answer is option C. Nuclear fusion. Most stars including Sun is made up mostly of hydrogen and helium atoms in plasma state. Sun generates energy from a process called nuclear fusion. During nuclear fusion, the high pressure and temperature in the Sun's core cause nuclei to separate from their electrons. Hydrogen nuclei fuse to form one helium atom. During the fusion process, radiant energy is released. Question number 19. The difference between a nuclear reactor and an atomic bomb is option A. No chain reaction takes place in nuclear reactor, while in the atomic bomb there is a chain reaction. Option B. The chain reaction in nuclear reactor is controlled. Option C. The chain reaction in nuclear reactor is not controlled. Option D. No chain reaction takes place in atomic bomb while it takes place in nuclear reactor. The correct answer is option B. The chain reaction in nuclear reactor is controlled. The chain reaction in a nuclear reactor is controlled by means of control rod and moderators, while in atomic bomb, chain reaction is not controlled. Question number 20. The concept of atom bomb is based on option A. Nuclear fission. Option B. Nuclear fusion. Option C. Nuclear embossing. Option D. None of the above. The correct answer is option A. Nuclear fission. The source of energy in nuclear reactors which produce electricity is nuclear fission. The enormous energy released in an atom bomb comes from uncontrolled nuclear fission. Question number 21. Otto Hahn discovered atom bomb on the following principle. Option A. Fission of uranium. Option B. Nuclear fission. Option C. Alpha radiation. Option D. Gamma radiation. The correct answer is option B. Nuclear fission. The source of energy in nuclear reactors which produce electricity is nuclear fission. The enormous energy released in an atom bomb comes from uncontrolled nuclear fission. Question number 22. The working principle of atom bomb is nuclear fission of uranium and the working principle of hydrogen bomb is option A. Nuclear fusion of deuterium. Option B. Nuclear fission of thorium. Option C. Explosion of bomb involving hydrogen gas. Option D. Explosion involving dynamite and TNT. The correct answer is option A. Nuclear fusion of deuterium. Such bombs which involve fusion of isotopes of hydrogen, deuterium and tritium are called hydrogen bombs. The energy released by fusion is 3 to 4 times greater than the energy released by fission, atom bomb, giving the hydrogen bomb more power. Question number 23. Hydrogen bomb works on which of the following principle? Option A. Controlled fusion reaction. Option B. Uncontrolled fusion reaction. Option C. Controlled fission reaction. Option D. Uncontrolled fission reaction. The correct answer is option B. Uncontrolled fusion reaction. Hydrogen bomb works on the uncontrolled fusion reaction process. Question number 24. Atoms which have same number of protons but different number of neutrons are called option A. Isotopes. Option B. Isobars. Option C. Isomers. Option D. Isotones. The correct answer is option A. Isotopes. Question number 25. Nucleus of helium contains option A. Only one proton. Option B. 2 protons. Option C. 2 protons and 2 neutrons. Option D. 1 proton and 2 neutrons. The correct answer is option C. 2 protons and 2 neutrons. Helium denoted by He has atomic number 2. It has 2 protons and 2 neutrons. It has 2 electrons also. Thank you for watching the video. If you'd like practice this quiz, then download the Wonderslate app now. Link in the description below. If you have any suggestion for us, feel free to leave comments. If you liked the video and want to see more of it, hit the thumbs up and don't forget to click on subscribe button to get more updates of the future videos.